Hey everyone! Welcome to TechNow Explained, where we break down how AI and technology are shaping our future in ways you might not expect. So today's topic? It's one of those terms that sounds super complicated but actually makes a lot of sense once you hear it explained right. We're talking about neural networks, the tech behind how AI thinks like a human brain. Spoiler alert, it doesn't actually think like we do, but it's doing something surprisingly close. If you've ever asked yourself, how can a computer recognize a face, write a poem, or even suggest what I want to eat? This is the video for you. Go ahead and hit that like button, subscribe to TechNow Explained, and let's crack open the brain of artificial intelligence. All right, first things first. What exactly is a neural network? A neural network is a type of machine learning model that's loosely inspired by how the human brain works. And by loosely, I mean very loosely. In your brain, you've got billions of neurons. When you see something, like a cat, certain neurons fire based on what you're seeing. Fur, whiskers, ears, etc. The brain figures out, oh, hey, that's a cat! Neural networks in AI work kind of the same way. They're made up of nodes, which are like tiny digital neurons. These nodes are organized in layers. You've got an input layer, one or more hidden layers, and an output layer. When you feed data into the network, like a picture, the information passes through these layers. Each node makes little calculations, and by the end, the network spits out a result like, that's a cat, or that's not a cat. It's not magic, it's math. But the cool part is how these simple pieces come together to do something that feels like thinking. So, how does a neural network go from clueless to clever? It learns through a process called training. And here's where it gets interesting. Let's say you want a neural network to recognize handwritten digits. You show it thousands, literally thousands of examples of the number 2, 5, 9, and so on. Each image is labeled with the correct answer. At first, the neural network gets things wrong, a lot. But every time it messes up, it adjusts. It tweaks the connections between nodes, a bit like how your brain builds stronger connections the more you practice something. This back and forth process is called backpropagation, a fancy word for, hey, that was wrong, let's fix the system a little and try again. Over time, the network gets better and better. It learns what curves and shapes make a 2 look like a 2, even if it's messy or written by a kindergartner. This same training process is how AI learns to do everything from translating languages to predicting the weather. Let's peek inside those layers for a sec. Each layer in a neural network is responsible for learning a different part of the problem. It's kind of like a factory line where each worker has one specific job. In early layers, the network might learn basic features, edges, corners, colors. In later layers, it combines those into more complex concepts, like eyes, shapes, or patterns. By the time the data reaches the output layer, the network has made a whole series of decisions to arrive at a conclusion. It's like building a face from pixels. Layer 1 sees lines. Layer 2 sees a circle. Layer 3 says, that's a head. Final layer says, yep, that's your friend Anna. The deeper the network, the more layers it has, the more complex and powerful it becomes. This is what we call deep learning. Okay, so we've said neural networks are inspired by the brain, but let's clear something up. AI isn't actually thinking. It doesn't understand. It doesn't feel. It doesn't know what a cat or a joke or a love letter really means. What it's doing is pattern recognition. It's crunching numbers and probabilities to make predictions about what comes next. You say, tell me a joke, and the network predicts what kinds of words usually come after that based on its training. It's like the world's smartest autocomplete system, but with zero life experience. Still, the results can feel uncannily human, especially when you're chatting with something like ChatGPT, or watching an AI paint a picture that hits you right in the feels. So where are neural networks being used today? Short answer, everywhere. Voice assistants like Siri and Alexa? Yep, neural networks. Face ID on your phone? Neural networks. Spam filters in your email? Again, neural networks. Self-driving cars use them to identify pedestrians, road signs, and other vehicles. Even medical diagnosis tools use neural networks to detect diseases from X-rays or MRIs. These systems are powering some of the most impressive technology we've ever built, and they're getting better every day. As powerful as they are, neural networks aren't perfect. They need huge amounts of data to learn, like thousands or even millions of examples. They can also be black boxes, meaning even the engineers sometimes don't fully understand why the network made a certain decision. And they can pick up biases from the data they're trained on. If the training data has stereotypes or mistakes, the network might learn those too. So yeah, while neural networks are super cool, we've got to be careful how we build and use them. All right, that's a wrap on neural networks. Let's break it down one more time. Neural networks are inspired by the brain, but run on math, not magic. They learn by adjusting their digital neurons through training. They work in layers, each one digging deeper into patterns. They're powering the apps, tools, and tech we use every single day. And while they feel smart, they're really just really good at guessing what comes next. If you learned something new, give the video a thumbs up, subscribe to TechNow Explained, and comment below what part of neural networks blew your mind or still confuses you. We might turn it into a whole video. Until next time, stay curious, keep exploring, and remember, machines might be learning, but we're still the ones asking the questions.